Hello everybody. As we approach the release date for my first indie game, Dune Raider, link in the description, I wanted to make a video talking about the feature I have spent the most time on. That being world generation. Back when I first started the project, I used a simple algorithm to determine the height map on the fly. Initially, this was to save on memory, as I could fairly quickly figure out what the height at any given point was. I knew that I wanted dunes in my terrain, so the first thing I thought of was using a sine wave. This would form long ridges across the world, and to make sure those ridges are not straight, I added purlin noise to the parameter of the function. This would offset the sine wave along the opposite axis, as well as create some variation in the wave length. This created some pretty decent looking terrain, but it didn't look like dunes. Desert dunes have a fairly unique shape, where they are pointed at the top and steep on one of the two sides. This is because they are formed entirely by the wind. So the wind will blow up against the slope, and once sand reaches the top, it falls over and forms the steep side. To create this effect, I simply swapped out the sine function with my own custom curve that I would pass everything into from now on. With the basics done, I needed some variation in my terrain, as I didn't want every single part of the world to look the exact same, so I needed some way to create biomes of sorts. At first, I had various Dune algorithms that were smoothly transitioned between using purlin noise, but as I came up with more ideas for biomes, such as canyons and an oasis, I realized this simple purlin noise gradient would not cut it. The way I handled this was I started by creating a grid of cells. Each square on the grid would have a random value assigned to it based on its position and the world's seed that determines what type of terrain is in that cell. Now the problem with this, of course, is that now all of the cells are simple squares, which looks pretty boring. So I fixed that using a Voronoi algorithm. Each square also has a point in it, randomly chosen within its area. Instead of determining terrain using the cell whose square you are in, the code now will use the cell whose point it is closest to. This creates more unpredictable shapes for the cells, and also causes a large amount of variation in the cell's size, which makes the world feel a bit more natural. In addition to these cells, I also added regions which act more like traditional biomes, and each region has its own set of cell types that can generate in it. So the difference between each cell is simply a matter of what kind of objects spawned there, as well as what the sand is shaped like, such as going from small dunes to large dunes. But a region can change the terrain significantly, such as going from those large dunes to giant canyons and mesas. With this out of the way, terrain was starting to feel a lot better, and the world was actually starting to feel fun to explore. However, with it came a few issues. For starters, the height map could no longer be generated on the fly. No longer was it a simple matter of plugging in a position into a function. I had to now determine which function to use. This meant not only figuring out which cell you were in, but how far inside of the cell you were, because I couldn't just use the height function for the cell I was in, because then I would have sharp edges on the border of each cell. So I had to program transitioning into it, where it would average the values given by every neighboring cell based on how close to their border you were. This was a lot of information to be generating every single frame for every single object on the terrain, because of how I handled the physics. So I needed to start storing all of these height maps that I am generating. With this, of course, comes race conditions, as I would have been multi-threading a lot of the world generation. So I had to figure out an efficient way to make all of these threads share the same pool of height maps. After all of this, it was on to optimizations. The first optimization that could be made with this terrain generation was to compress it. At first, I was storing a point on the height map for every half of a meter, because it matched the resolution of the meshes I was creating for the chunks. But this meant that for every 100-meter chunk, I was figuring out the height for over 40,000 points. And as mentioned before, in order to create smooth transitions, each of these points has to figure out its distance to add at most 4 other points, to then create a weighted average of various generated height values. However, I figured out that I could store a lower resolution version of this height map, take advantage of the terrain's smooth nature. I could now store a point every 5 meters and use a Bezier curve to predict what the height values are in between points. This makes for much faster terrain generation, and also helps to smooth out a few problems I've been having up to this point, as sometimes the transitions don't work entirely as expected. But with Bezier interpolation, it smooths out all of the previously sharp cliffs. Now, if only I could take this Bezier curve interpolation and carry it over to the rendering side of things. As it turns out, I can, using a type of shader known as a tessellator. With tessellation, you can create a low quality, low resolution mesh or object and create new vertices on pre-existing faces. And this is done every single frame on the GPU. This means that not only can I create a low resolution mesh that the GPU will add more detail to, but I can also use it to create a level of detail system, only adding more triangles wherever they are necessary. The desired resolution of the tessellated mesh is calculated based on not only distance, but also the flatness of the surface. In smooth, flat sands, I don't really need extra polygons. Limiting tessellation to the sharp curves on the mesh, such as at the top of a dune, greatly improves performance and vertex count. And that summarizes all of my work on the terrain generation over the past 2 years for my sand surfing roguelike Dune Raider. If you want to see more, be sure to subscribe to my channel, as I will also be covering how I handled the physics for this game next time. You can also wishlist my game on Steam using the link in the description. It will release on December 13th, so it is coming soon. And I will be releasing a video explaining the physics in the next week. But until then, stay safe.